students, we are discussing integrals of the form e raised to x into brackets f of x plus f dash of x dx. Let's take an example in this particular module. It says evaluate the integral e raised to x into 1 plus x square upon 1 plus x the whole square. My dear students, let us see the solution. Now, if I have to simplify this particular integral, how should I proceed? You may observe, my dear students, that here I have to convert the integral in the form of e raised to x into brackets f of x plus f dash of x. That is 1 plus x square upon 1 plus x the whole square has to be broken into two parts such that one can be taken as the function and the other can be taken as its derivative. Observe, my dear students, that the denominator has x plus 1. So, we should write the numerator also in terms of x plus 1. And for that, what we will do is, we will add subtract 1. Let us see that step. So, here 1 plus x square upon 1 plus x the whole square is as it is. To convert the numerator in terms of denominator, what we are going to do is, we are going to add and subtract 1 in the numerator. So, let's add and subtract 1. So, in the next step, can I write e raised to x as it is? And now, can I say 1 plus 1 is nothing but 2? So, in the next step, let me write a 2. Now, x square minus 1. Can I say x square minus 1 can be written as x minus 1 into x plus 1 divided by the whole divided by x plus 1 the whole square. Correct? So, my dear students, you can see what we are trying to do here is write the numerator in terms of denominator. You may see there is a x plus 1 in the numerator now and there is x plus 1 already in the denominator. Now, let us see the next step. Now, the result which we are going to use requires two parts inside the bracket. So, obviously, we have to separate here. Now, when I am writing the next step, my dear students, I am just rearranging. The second part, let us write first. So, we will have x minus 1 into x plus 1 divided by x plus 1 the whole square plus 2 upon x plus 1 the whole square. Dx has to follow. So, that is, in the next step, I will have a e raised to x into, can I say x plus 1 up in the numerator and x plus 1 in the denominator will cancel. So, we will have e raised to x into x minus 1 upon x plus 1 plus 2 upon x plus 1 the whole square dx. Now, my dear students, it's a trial and error for you, but I know that if I take f of x as x minus 1 upon x plus 1, its derivative, that is f dash of x, will be equal to how much? It will be x plus 1 into derivative of x minus 1, which is 1, minus of x minus 1 into derivative of x plus 1, which is again 1, divided by x plus 1 the whole square. So, that is nothing but x plus 1 minus x plus 1 divided by x plus 1 the whole square. Now, my dear students, the x in the numerator will get cancelled and what we get is 2 upon x plus 1 the whole square. If you observe, can I say now the integral is of the form e raised to x f of x plus f dash of x. This is the integral. Now, as per the result, can I say the answer is e raised to x into f of x plus c? Therefore, we can say the answer is e raised to x into brackets x minus 1 upon x plus 1 plus c. That's our final answer. Now, my dear students, let's take an entrance question. It says integral of e raised to x into brackets 3x square plus 4x plus 5 dx. Now, one method of solving this particular question is you differentiate the options and check which one will give you the question back. But we'll see the actual method. Now, my dear students, here the highest power of x is nothing but 2. And what we have to do here is write 3x square plus 4x plus 5 such that it can be broken into two parts. One is f of x, the other is f dash of x. So, what do I observe, my dear students? Highest power of x is 2. And what is derivative of 3x square? It is 6x. So, can I say the power of x in that is 1? Correct? So, here we will have f of x in terms of x square and f dash x will be in terms of x. So, let us put 3x square in terms of f of x is as a part of f of x. Now, if f of x is having 3x square, f dash x should have its derivative, which is nothing but 6x. So, let us write 6x as a part of the f dash of x. But my dear students, if you observe, in total we have only 4x with us. So, what we have to do is we have to do a minus 2x. Because we have only 4x with us, we do a minus 2x. Now, if I am writing minus 2x in f of x, its derivative should also be seen in f dash of x. So what we will do here is add a minus to that 6x. So we will get a minus 2 here. But my dear students, effectively we should have a plus 5, and therefore we add a plus 7 to the f of x. So effectively derivative of 7 is 0, so no further adjustment is required. Now if you see, my dear students, the integral is of the form e raised to x into brackets f of x plus of f dash of x, and that is going to give me option C as the correct answer. And that's how we approach this particular question. That's all in this module. Thank you very much.